Great, thank you. It's a great honor to be here. Today we want to talk about the robustly optimal pricing for advertisement service, or more generally speaking, for quality disclosure service. So actually, our paper also speak to certificates, so it's a good session to be in. So nowadays, advertisement platform play an important role in in the information transmission in today's marketplace. And those platforms, they control the access to consumers' attention, and they can charge producers for disclosing their quality information to the consumer on the platform. However, when doing so, the platform faces a problem of strategic uncertainty. Okay? This is illustrated in this graph. The producer's willingness to pay for the ads is actually endogenous, because it would depend on the consumer's belief about the product when they do not see the disclosure. Okay. This is important because it affects the producer's outside option of not purchasing the ads. Further, the consumer's belief about the producers actually depend on the producer's contingent equilibrium purchase decision, because the consumer would try to infer Bayesian inferences when they do not see the disclosure. To complete the loop, the producer's equilibrium behavior definitely depends on their willingness to pay for the ads. So it is this interdependent structure that creates multiple equilibrium and strategic uncertainty. And in this paper, we are interested to understand what is the robustly optimal pricing strategy for the platform if it aims to maximize the revenue guarantee across all equilibrium. To give you an overview of the results, first, we show that it is optimal for the platform to offer a continuum of advertisement plan that induce strictly increasing marginal price for more publicity. And interestingly, almost all of those continuous plans are off-pass. They are never chosen by any producers. Their existence merely serve as a profitable deviation for the producers to break undesirable equilibrium. Second, we show that the platform would prioritize attracting high-value producer, which gave a higher rent, despite in the benchmark, in the traditional case, if the platform can select the equilibrium, then every type will get full surplus extract. Okay. Lastly, we show that even if the platform can design the signal structure, can potentially add in noise, it is optimally for them to not so. So the platform would actually fully review the type. It's a short presentation, so let me jump to the models. So there will be a producer who sell a product of value theta to consumer. The value is finitely supported with a common prior. The platform can obtain a hard evidence that fully review the value, and the platform would offer a type-specific manual of advertisement or disclosure plan to the producers. In particular, for each type of producer theta k, she would receive a manual consist of multiple pair, QI and PI. If this type theta k chooses a QI PI, then the producer would pay the platform PI, and the platform would disclose his type with probability QI. And we always let 0, 0 to be in the manual, so that this is the outside option of the producer. The timing of the game goes as follows. So first, the platform publicly commits to a profile of menu. And then second, the type of the producer is realized and observed by both the producer and the platform. Third, the producer privately choose an advertisement plan in the menu. Here, privately means, importantly, that the consumer do not see what is happening. So the consumer do not know what ad plan the producer choose. Fourth, the platform would publicly disclose the quality information with the chosen probability Q. Okay. And next, the consumer form posterior about the value of the product, and according to whether they see the disclosure or not. If they see the disclosure, the belief is degenerate. Okay. If not, they have to do a Bayesian update. And finally, after all of things, the producer would sell the product exactly equal to the posterior mean of the consumer. Okay.
Sorry, that So I got this. You mean that the buyer does not see the choice?
Yes, the buyer does not see the choice. So the buyer, when the buyer see no disclosure, it does not know which type is coming.
So they don't even know whether they chose 00.
Yes, it could be that they choose a half disclosure, but by bad luck, the consumer do not see it. So the consumer have to think about all these possibilities.
This is a realistic assumption that
I think because it's like the trade deal between the producer and the platform. So like you don't really know whether.
But in this case, you don't even know whether he went to the platform, because 00 is basically like choosing not to.
Yeah. I think it's reasonable, right? So it's like if you never see ads for a product, you don't know whether they are so poor that they don't purchase any ads, or like they just purchase a limited ad that does not reach you. So that's the assumption. Yeah. Okay. So now what is the platform's objective? So for any manual profile that the platform commits, we define a disclosure equilibrium that the user's contingent choice of plan. So each type would choose ad plan within the manual, and the consumer's belief system. Okay. We use the standard notion of weak PBE, which requires sequential optimality and Bayes rule whenever possible. And the platform ER model is ambiguity averse, so it chooses a manual to maximize the expected revenue in the worst case disclosure equilibrium. So that's our robust design. Okay. To illustrate the one key insight, I will start with the binary model. Everything I said in the presentation generalized holds for multiple types. Okay. So for now, let's say there's a high type whose value is 1, and there's low type whose value is 0, and the common prior of high type is mu. It's actually easy to prove that it's impossible, it's never optimal to serve the low type, because low type would never willing to disclose the fact that he is the lowest possible type. Right? So actually, we just need to focus on the design of high types, man. Let's start with the benchmark where we assume that the platform can select its favorable equilibrium as it is a canonical approach in mechanism design. In this case, the following binary menu is actually optimal, where the platform essentially sells full disclosure at price 1. Okay, and in the optimal equilibrium induced by this menu, the high type would always choose to fully disclose. Okay. This is an equilibrium because in the equilibrium, when the consumer do not see the disclosure, they correctly anticipate that, infer that this is a low type consumer. So the posterior mean is just 0. Okay. So the high type if the high type does not purchase ads, it would get 0. Whereas if they disclose themselves, they can sell the product at 1. So they are willing to purchase the disclosure and get full surplus extracted. However, the problem is in the same manual design, there exists a bad equilibrium where high type never disclose. This is because if the high type never disclose, then in the equilibrium, when consumer do not see any disclosure, it do not do any Bayesian updating. Okay, so the posterior are equal to the prior. And so the outside option of the high type now become mu instead of 0. So the disclosure fee is too high. Okay, so there are two equilibrium. This observation actually generalized, so this also holds for multiple type, by the way. So we have a result say that for any manual profile that induce a good equilibrium where the revenue is close to first full surplus extraction, it also induce a bad equilibrium where the revenue is close to 0. So this suggests that there's a large degree of strategic uncertainty to the platform, and that's the one main motivation why we look for robust design. Now, restricted now we'll go back to the robust design. So let's start with the two-plan manual, because typically revelation principle tells us it's without loss to focus on the design on the plan that high type would choose. Okay, we'll see what would happen with binary plan. In this case, the following two-plan manual is actually optimal, and the profit that we get from the high type is 1 minus mu instead of 1. Okay, this is very intuitive because to robustly induce disclosure from the high type, we have to eliminate the equilibrium where the high type choose the outside option. Okay, and in this candidate equilibrium, when high type choose not to disclose, as I've told you, the consumer's posterior mean, skepticism belief, we call it, is equal to the prior. So the service fee for the full disclosure cannot exceed 1 minus mu. So this is the optimal one within the two-plan manual. But actually, in our setting, reverse principle fail. So we would benefit, we would increase our profit guarantee by introducing more plans that are actually off-pass. To illustrate this point, let's look at this three-plan manual, where we add a second option of a half disclosure at a price of 1 minus mu times a half. The price for full disclosure now change a little bit. I would explain it to you later. I want to make sure that this three-plan manual actually robustly induce full disclosure from the high type. How can I do that? First, I want to make sure that zero disclosure is not equivalent. Okay? This is guaranteed by the design of this half disclosure, right? The price of the half disclosure is 1 minus mu, the critical value that we just discussed, times the probability distribution. This means that suppose we're in a hypothetical equilibrium where high type never disclose, the consumer's belief of posterior mean is mu, and then the high type would find it profitable to deviate to the half disclosure. Now, next, we want to make sure that this half disclosure is not equilibrium. So that's exactly how our price of full disclosure is constructed. So in this hypothetical half disclosure equilibrium, the consumer's skepticism belief is some value, mu. And this mu actually is strictly smaller than the prior, because now the consumer knows with some probability that the high type will disclose. So no disclosure becomes a bad news for the value of product. So this posterior mean should be strictly lower than the prior. We set this W exactly equal to mu. And so for the same reason above, then the high type would find it profitable to deviate to the full disclosure, right? Because we just set the minimum price that, the maximum price that he's willing to deviate. So we ensure that there's only one equilibrium where the high type choose full disclosure. And importantly, as we've argued that this mu is strictly smaller than the prior, because when high type is disclosed with some probability, no disclosure is the bad news. So this means that the price that we have here with three-plan manual is actually larger than what we have with two-plan manual. Okay. So the key insight I want to highlight in this illustration is that it is less costly for the platform to break equilibrium when high type disclose more, because the consumer would become more skeptical when they do not see the disclosure. And so the producer's outside option get reduced. As you can imagine, we can add more and more plan into the manual. So in the limits, the optimal manual would have a continuous of choice and for all disclosure probability, and we assign a price for each disclosure probability. The price function satisfies the following differential equation. So to understand this, suppose we are in a hypothetical equilibrium where the high type just disclosed with probability Q. We know that we denote the skepticism belief of the high type in this case as W and Q. Right? And the construction of this ensure that in this candidate equilibrium, the high type would find it profitable to slightly have more disclosure. Okay, so the construction of this ensure that the high type would kind of resist himself increasing the disclosure all the way to full disclosure. Okay, and we get a nice expression of the revenue as well. There are some challenges to generalize this finite type results to multiple type, additional challenge, but I don't have time to talk about it. In the full model with multiple type, we still have a similar formula that we just illustrated, where you can see that the price for each type satisfy this differential equation. The derivative equal to the type minus the outside option, some kind of consumer's posterior. The only trick here is that this Wn, what is this WNQ? This WNQ is the consumer's skepticism values of posterior mean when all type higher than this theta k fully disclose, and all type lower than this theta k never disclose, and this particular type of theta k disclose exactly with probability Q. What this construction ensure is the following procedure. So first, the construction for the highest type eliminate all the possible equilibrium where the highest type not fully disclosed. And that the highest type must disclose, fully disclose in any equilibrium, the construction of the second highest price eliminate all equilibrium where the second highest type is not fully disclosed, and so on and so forth. So in the end, every type except the lowest type fully disclosed become the unique equilibrium of the game. Okay, so that's the main results. Let me quickly talk about some extension as I've promised. So far, I just talked about a fixed evidence structure where the signal just fully review the type. We can actually talk about what if the platform can design a harder evidence. So we design the signal structure, potentially add some noise into it. And we actually show that it's always the case that more precise signal will lead to higher profit guarantee. And as a consequence, the platform would prefer full reviewing signal as the outcome. This is in contrast with the QG paper by Ajib et al., where they find that the optimal signal structure is noisy if the platform is restricted to sell full disclosure at a type independent price. So basically here what we find is that if you enable using flexible pricing scheme, then it would simplify the optimal signal structure. I get two questions from Elliot and Daron, so I will answer them preemptively. So first, our results generalize if the principal want to maximize robust guarantee across all rationalizable outcomes. So actually, we can show that the optimal manner that we just tell you induce full disclosure as the unique rationalizable outcome. And second, that allowing random contract does not improve our robust guarantee, but it does introduce another implementation of our optimal mechanism. That is, you can try to sell full disclosure only, but at a random post price. And the producer, regardless of the realization of the random price, would always purchase. Okay, so I think this speaks better to the certification application because it's hard to imagine intermediate disclosure probability in that kind. So to conclude, we consider the robust pricing strategy for quality disclosure. We showed that the platform will offer a continuum of advertisement plan. It prioritizes attracting high value producers, and they prefer precise signal. Thank you.
So does that depend on the fact that the platform can choose any queue they want? Suppose that you add the cost, the like more precise signals with higher probability for revealing are more costly for the platform.
Yeah, I think the result is actually robust because like basically to tackle strategic uncertainty, they are independent because the cost is yours. You don't care about the interaction. It will not create additional because the platform has commitment, right? So the cost is incurred to the platform, so it does not interact with strategic uncertainty. So it just enter the objective function. So it change a little bit. It's no longer the truth that you always want to induce full disclosure, but you still have the signal structure and this like increasing paths and everything else. We do have an extension.